thank you very much for the nice introduction and also the opportunity here to give this keynote. I think I've been participating at your workshops or conferences here quite a few times, and it's really great to see this progress you make in order to get people together and to form strategies for very interesting topics. And when I say interesting topics, I mean topics in this context for our industry, the cement industry. And I was, of course, when you asked me to give this keynote, very much willing to contribute here. And as we discussed before, I'm drawing the picture a little bit bigger, and you will see, if you look at our industry, that there's a strong link between decarbonization and circularity. So although the topic here today is more on the circularity aspects, I would draw the picture a little bit bigger, and you will see if you have this kind of holistic approach, that might also help to fine-tune, legislation, or also the practical experience in the plants or along the value chain. So, I don't have to show you you can see that my slides are slipping. Yeah, it's the next slide. Yeah, okay.
Yeah, works well.
Okay. I don't have to tell you the value chain of cement here, but it's something, of course, that's important, that we are not alone as cement producers in the value chain. Yeah, we have suppliers of raw materials, of fuels, and of waste fuels in this context, and we have, of course, customers. Yeah, and at the end we have a product which is a construction piece. Yeah, it's an infrastructure, it's a building, and of course we have to ask ourselves how we can recycle this material back into the value chain. And there, of course, there are organic parts and there are inorganic parts in this, and it's a very complex system on the one hand side, but on the other side, we all know that it goes hand in hand, and it's very nice to see how that has developed over many years. And I think it's also this conference here shows that there's a very, very good link along the value chain when it comes to the different topics. So the global, or the more holistic view starts in the quarry of our cement plant, and it goes along the value chain towards the building or the infrastructure that has a service life, and that at the end has to, of course, be thought of how can we take advantage of that building in a material or resource sense. Now, the three topics I would like to touch upon is alternative fuels, recycled concrete fines, and the decarbonization of clinker production. And you will see that there seem to be independent topics, but as I said before, they are kind of interconnected. So there's a strong relationship between them, and it is, of course, cross benefits. There are challenges in common, but there are also cross benefits, of course, that we can draw. And I think it's very important when you go into the details to make sure that the other parts here are also part of the big puzzle to be seen. Now, the alternative fuels, the impact is, of course, saving on CO2 emissions. We are closing the material loop here through co-processing. That is all well known to you. I think I don't have to tell you. I picked one aspect of the huge amount of building material resources and the recycled concrete fines as an example, that we can close the loop here with respect to material. That we have new substitute for clinker in our cements, and we can also use, of course, the fine to recarbonate. That means also contribute to decarbonization. And then, of course, we have the big topic of decarbonizing our clinker processes, and I don't have to tell you that is one of the biggest challenges we are anticipating in these years, and that is the question of how can we avoid or eliminate the unavoidable CO2 emissions. And this is where all I think at the end comes together, and I think that's the holistic view I would like to tell you to talk to you about today. Now, you are all experts in the value chain. You're operating along the value chain, different aspects, even if you are really an immediate part of this, or if you are kind of from the academia in order to look at this in different aspects. But what is really, I think, unique here in our value chain, when you go to the very first part of clinker burning, We have something that is really, really unique among all industrial industries, among all industries. And this is our process, which is a high temperature material transforming process. And the beauty of it is, and that has been developed over many, many years, we have a counterflow of gases and materials, which is the base for an extremely high thermal efficiency. If you compare the thermal efficiency of a cement kiln with others, you will see that we are in the, depending on how you define thermal efficiency, we're in the upper 80s percent. And that is due to the fact, indeed, that we have a counterflow here, that the material that leaves the kiln, is cooled with our cooler. So the expert among you will know what I'm talking about. And then you have the gases heating up the material. And once they have heated up the material, they more or less cool down along the kiln line and the preheater. And you have exit temperatures, which are really, really very reasonable. And even if the temperatures are low already, you can still take advantages for low temperature drying processes. That is the efficiency. The other thing is that if you look at the gas temperatures, we need gas temperatures which are 1800, 1900, or 2000 degrees in order to reach the material temperatures of 1450 degrees. This is the key temperature you have to achieve in order to become the clinker hydraulic to the degree that we can work with it today in concrete. And hydraulic means that the product at the end hardens with water, with all the beauty aspects that we know, durability and things like this. So that is, we need to have these material temperatures. If we don't reach them, we have a problem with the reactivity of the clinker. Now, this goes along with a huge residence time. If you look at the material, the residence time in the sintering zone is 10 seconds here. That is extremely that is the gas retention time here in the kiln. In the calciner, we have 3 to 4 seconds, even at temperatures higher than 900 degrees, 1000 degrees, which complies with all the legislation for the incineration of waste. Here at the kiln sintering zone, we comply with by far, we over-comply, to say so, with the requirements of the incineration of hazardous waste. So it's an extremely suitable process for any type of materials to be burned. Now, when I say any type of material to be burned, I mean the combustion characteristics and their contribution to the process, and you will see in a minute. But nevertheless, we have to make sure that the materials that we are using fits to our product. So there is a difference to waste incineration. We can take advantage of high caloric and low calorific waste fuels, but they got to be pre-treated and quality control. And this is, I think, the difference to a typical dedicated waste incinerator. Now, this is to be seen against the background of the material, but that comes with the waste fuels, the materials. You could call them the ashes. So we have a combustible part and we have a material part, and that is of course why we talk about co-processing. Co-processing means that we process the energy and the material. And because we also take the material as something that is inherent for our clinker, we got to make sure that the material, of course, is in compliance with what we need here. If you look at the ternary diagram here, you have the calcium oxides here, or basically the lime. Then you have here the silicates, and here you have the aluminates and iron. And the clinker has this composition here. And all the materials that we are using, of course, contributes with the ashes or with the raw material to the clinker composition. And what you can see here is a huge area of different kind of materials that qualify for alternative materials in our kilns. And if you take this into account, you can really see that they contribute very, very nicely to the clinker composition. And the most famous example here is the used tire. And you all know that the tires have, because of the rubber, have a huge amount of combustibles. The organic part is an extremely valuable fuel in many kilns in Europe. But we have also an iron part from the iron, the steel belt, to say so, in the car tire. And I can tell you that in many plants, the iron contribution to the kiln is to the clinker kiln is an essential part of the clinker composition. If you had not the tires in these cases, you had to look for other iron sources, be it natural iron sources, iron oxides, for example, or other waste materials. So I'm saying this, that we also take advantage of the inherent inorganic material. And I don't have to tell you the characteristics here. It's a real contributor to circularity. We prevent landfilling in many cases here. And of course, we also minimize the respective investment into new waste treatment plants. And the European legislation, which I will touch upon in a minute, takes this into account, of course. And that comes here, and I will not go through this because there are better experts to explain this. I think we have a good waste framework directive here in Europe, touching upon municipal waste and packaging waste here. The question of what can be landfilled until what time, and also the collection, or let's call it the overall waste management. And I think that is very well introduced for the benefit of the environment, to say so. And I think it has been, the exercise has been gone through for many years now. It's also from an economical point of view, it's something that is kind of in a good balance here, and it's really beneficial for from an economical point of view, but also from an environmental point of view. And I have to tell you that that is something unique here in VDZ, and together with ECA, we are just working on the roadmap, decarbonization roadmap for the Philippine cement industry. To give you one example, and then there starts, looking at alternative fuels at a much lower level than here in Europe. And you will always come to the same questions that we had 20 years ago here in Europe. The question: how do you set up a proper waste management system? It's not the question of the kiln in most cases, or the cement plant. It's more the question of how can you provide sufficient amounts of suitable waste that can be pre-treated and then used as alternative materials. And when I say sufficient amount, that means we have to have the quality stable over a certain period. So we cannot just pick pieces here and there and just give it to the kiln. No, we have to make sure that we have an even and homogeneous material flow over time. Now, this is the situation in Germany. You can see the development here of the substitution, the thermal substitution. So the last figures here are from 2023. We only get the figures with a year delay, and therefore this is the most recent one. But you can see here in the similar situation we have, for example, in Austria and in other European countries. It's really fascinating to see how that has developed over the years. When I started in the sector in 1991, we had a very slow substitution rate here that were the used tires at that time. And the second material that we used at that time were used oils, waste oils, and they were at that time contaminated with PCBs from the old transformers. And the government had an issue, of course, to get rid of these PCB-containing oils. And they asked the cement producers whether we could take advantage of this. And the cement producers, of course, were hesitating because to be seen as an industry in the context of PCB-containing oils was not seen as very lucky situation. But nevertheless, we did 2 trial tests at 2 different kind of kilns. And of course, at the high temperatures, it was clear from the beginning. But the kiln tests have proven this, that the PCBs were completely destroyed. So that was kind of where we really could show that we could give a higher benefit to the society than we expected at that time. And of course, it was a starting point of getting more openness with respect to more alternative fuels in our kilns. Now, I'm not going through the different kind of materials here that can be used after they have been pre-treated. There are better experts here in the call than me. I can give you just an overview here of what is done. it all has to be pre-treated, that's what I said. But the aspect that, of course, is also important for us is here when it comes to CO2 emissions, the biogenic part. And there are, of course, some waste which are, basically fully fossil, to say so. And then we have others that have a certain biogenic part. And you should not forget that under the emissions trading scheme here in Europe, and I come back to this in a minute, we really have an issue here with the question of how can we provide as much biogenic containing fuels here in order to reduce our emissions. By the way, that's also the case for the raw material, but let's touch upon stay with the materials here, which are used as fuels at that time. Now, there's still an open question that goes beyond what is on the agenda today, but I would like to tell you that it's always the question of, can we not substitute our fossil fuel based by hydrogen, which by definition is not emitting any CO2, but the question of hydrogen is whether we can have sufficient amounts in the time to come, and second, at what cost. And third is there are probably better solutions to start using or taking advantage of hydrogen than just burning it in a cement kiln. Yeah. So we have many other industries which have a real need for hydrogen or for other better purposes than just using it as a fuel. And of course, the hydrogen has to be green. Yeah, that is something that is very important. So it has to come from green energy. And sometimes I have to say the European legislation is probably not could be more positive on this when it comes to hydrogen to be used in the industrial sector for decarbonization. Now, when you look at the Green Deal, and that switches over now to the question of how can we combine the use of alternative fuels with reducing our CO2 emissions. And you know that the Green Deal has many aspects here, and I will not go through this, but one of the aspects is for us now very important is the emissions trading scheme. How we have to reduce our emissions in the time to come, and how we can, and that is something it's a little beyond the presentation today, but I will just mention it to keep the industry competitive against imports. Once our CO2 costs in the operational costs are much higher than we have them today. And you know that we have to buy certificates or we have to invest in decarbonization measures. Both of it costs money and increases the production costs and makes us vulnerable to imports. This is a picture I think some of you know, and you can maybe understand once you look at this in detail in what a difficult situation the industry is. What you can see here are the certificates under the European Emissions Trading Scheme, the ETS. And these certificates, as you know, are dealt with in commitment periods. So this is the second commitment period. You get the third one, the fourth one. We are now on the fourth, and if you read the press, you know that we are talking about the second half of this year and the update of the emissions trading for the fifth commitment period. And you may know that the ultimate goal in Europe is to be climate neutral by 2050. Europe as a total, but they have on a European level they have picked the point sources, and these are the industrial and the energy point sources are the ones covered here by the ETS, and they have on the agenda to reduce the emissions much quicker. And that is done in the emissions trading scheme by issuing less and less certificates. So that was a stable number of certificates here, and you can see the LRF means linear reduction factor, and by law the linear reduction factor reduces the amount of emissions each year. And that means there's less and less emissions available. That means at the end, when there is no emission certificate left here, you cannot buy them anymore. And that means if you don't have certificates at hand at the end of the year, that basically you are not allowed to you lose, to say it in my words, the permit to operate. And that's a huge, huge challenge for our industry. Now, this is current legislation. So if it stays like this, and the LIF, the linear reduction factor, had been updated to 4.4% in the last revision of the ETS directive. So we end up in 2040 with no new certificates being issued anymore. And this is a real, real challenge for our industry. It goes much beyond the question of how can we use bio parts in the alternative fuels, but it goes to the question how can we deal with the CO2 that still remains at stake from our process emissions. Now then when you have the CO2, and that brings us back now to the material that we are talking about. When you have the CO2, the question is when is the CO2, when you capture it at the kiln, when is it recognized as a CO2 reduction? So, and the capturing of the CO2 has to be done in a permanent way. And of course, you can capture the CO2 and then you store it underground. That is one thing, but you can also consider to bind it in long-term binding products. Yeah, that is in chemicals, for example, if they are permanently bound, and that is a big debate when you use the CO2 for chemical processes, for example, as new feedstock. Question is it still, permanently bound? And you have also heard about the sustainable aviation fuel when you take the CO2 and you convert it into a fuel. To what degree can that be considered as permanently bound? And of course, there's a long debate on this, and I think I will not go to the details here. But what is really good is that if you recarbonate some of the materials that we know as resources in our value chain, we can carbonate them, and then we have mineral carbonates, and then they are seen as binding the CO2 in the long term, for sure. Yeah, and calcium carbonate is unless you heat it up again to 950 degrees, it's very, very stable. So that is something that the industry is looking in great detail, and the reason is twofold. First of all, from a circularity point of view, because the materials that comes from the recycling of demolition and construction materials is seen as a valuable raw material for cement to some degree, but also for concrete, for aggregates. But the fines, for example, if you treat them properly here and you expose them to CO2, they recarbonate, and of course they also provide an additional CO2 sink to be accounted for under the decarbonization topic in our industry. And this is not boring you with too many slides here from standards, but that gives you an idea. F means recycled concrete fines, and you can see here all the potential materials in cement, and the abbreviation of this is the clinker. We have the concrete fines here. We have the ground granulated plastone slag here. We have the fly ash, for example, and we have the limestone, to just name the most important one today. And these are new cements. They start with cement 2. I have not listed the other ones here, but the new cements are the ones, for example, with this concrete fines here. And you can see you can go up to 20% of recycled concrete fines in tomorrow's cement. The legislation is there, and the concrete fines are dealt with more or less like limestone. I mean, they are not reactive, but they are carbon neutral. And because of their fineness and because of their surface, they still contribute to some degree to the strength development and to the performance of cement. So that's really, really good news. And many companies are working on this. And the main topic, again, is, you remember what I said about the waste. You need a certain management to collect these materials and to pre-treat them. And there's one pilot now being in Poland, where the recarbonation of these materials is on the agenda. And I'm really excited about this. And I think it's good news, again, from 2 points of view, circular economy point of view, and also from a CO2 point of view. And that really shows that these two big topics, they go hand in hand. Now, we have done in our country a study on the materials that we deal with, and this is on the left-hand side. You see the overall primary raw material situation in our country. how that is distributed, of course, to the primary raw materials. We also call fossil energy sources, although it is coal, for example, and it's oil here. But that is not so important for us here. But you can see let's go here first. Yeah, the primary raw materials for cement and concrete. So we have limestone, we have gravel, we have sand, and you can see here. As compared to, for example, biotic raw materials that we also have, of course, and other mineral raw materials, that we are quite a significant taker of primary raw materials. And we have asked the question, I mean, is that going to be today the same as in the future, the same as today? And how can resource efficiency also contribute to building up circularity and recycling cycles? So what we have done here is, this one here. I'm sorry. This one. There's my mouse here. No, sorry. This part here. When you transfer this to again 100%, and you ask yourself how is cement and concrete being composed of, you see that we have roughly 240 million tons per year of material, just pure materials. And you can see in our value chain, and that is of course here gravel, sand, and basically that all of you know as aggregates and concrete. And then we have limestone, yes, primary raw material, and a little bit of fossil fuels and other materials. So this is quite a significant amount, and you can imagine that from a circularity point of view, there's a strong focus in our industry to really make sure that we take the best advantage of the possibility to give materials that have been used back into the value chain. We have done a resource roadmap here that you can look at in our roadmap, and it was very helpful because there was a lot of clarity that we were able to create, showing what is possible, but also what is not possible. Yeah, and I'm just concluding the final aspect here, that we still have to rely on primary raw materials. We cannot fully close the cycle for many reasons. Now, what we then in this context have looked in detail is if you start at the value chain from clinker, cement to concrete. Yeah, you have here the raw materials for clinker, and that is basically what the cement industry takes from its quarries, and it's then burned, and we have the alternative raw materials here, and we have the red ones are the sand that we are using, the clays, and so on. So these are the inorganic parts. And then you go to cement, and you can see that cement, and we have a clinker factor in Germany from 71%. At that time we had that, so that means that the clinker goes then into cement, and you can see that we have other alternative raw materials here that we are using. This ground granulated dust furnace slag, and this is here the burnt oil shale. It's limestone, and of course we still have as a setting controller here. We have the natural gypsum or the anhydride. Now the next story, of course, then is to go from cement to concrete, and again, yeah, you have the cement is the smaller part here. And most of the concrete is, of course, aggregates, which is sand and gravel, and material that we take as primary or as recycled raw materials. And you can see here the alternative raw materials today are rather low in concrete, although the reuse of construction and demolition material is quite high, not only in our country but in all over Europe. It's not to the first degree used in concrete yet. So it's quite a bit. It goes to road bases and similar things. So that means although recycling index is very high, there's still, I think, a huge potential here for closing the loop also in concrete. And that is the question, of course, what does this mean in concrete? What does it mean concretely, to say so? So I mean, and you recycle into clinker, you recycle into cement, you recycle into concrete, and you could reuse some of the materials in construction. That is something that comes up here in the time to come. The question of extension of the service life of buildings by reusing elements, or just keeping the structure of a building and not taking it completely down. There's a new development coming here. And that is also part of our roadmap for decarbonization, because it's not only that you don't need the material, but it's also that you don't have to use cement or concrete for this new ones. Okay, then this is just in a nutshell the final outcome here. We have as I said before, roughly 240 million tons of primary raw material, and then if you go from today, 2020, at that time that was today, of course now it's 2025. Actually, we did the roadmap here in 2023, but the data that we had is from 2020, therefore that was the basis. And you go to 2050, you can see here there is a lot of saving potential possible, yeah, but you still have to rely on primary raw material. So, and that has to do with the quality of the material and with the availability of the material, because there's still more material brought into the value chain that then it's coming back from taking buildings down. Yeah, so because we still built the big reservoir of our built environment is still there, and that is, I think, one of the reasons that we, for good reason, talk about urban mining in the time to come. And it starts today. And if you look at who is investing in recycling plants, for example, you would see that those dealing with these kind of material flows are prominent here. Now, the summary of my presentation is, and I think that was what I could make clear, that decarbonization and circular economy, they go hand in hand. I think I've said that outlined that the alternative fuels, they still play a very important role. Of course, more than 100% is not possible. So we are approaching here in our country it's kind of a limit, where it's more the question of what are the materials of the future. And it's also clear, I think, that we have to focus on the entire value chain. It's not only that we have a single aspect of it to focus on, but I think we have to look at the whole value chain. And the message, of course, is here for environmental, but also for economical reasons. I think that it's always worth to promote waste management and co-processing to contribute to the use of alternative fuels. But I think I also was able to show that the recycling of concrete can give a huge impact to the material aspect of the value chain beyond the combustible part. I think we have to make sure that we use our raw materials as efficiently as possible, and that means we have to close the loop as best as possible. There is still a potential here to lift for both aspects, the fuels and the materials. It's a big challenge to build up the management schemes to make sure that, for example, when concrete is taken down, when a building is taken down, that it's separated nicely from the other materials, and then can be collected, transported. Logistics is a big issue here, and then to really contribute to a closed loop here. Having said this, I would like to thank you very much for your attention. I hope that I was in time. I will stop sharing my screen, and I'm available for questions now, or I understand that at the panel discussion later, I think we will have ample of time to go to the details of what I have said here. Thank you so much for having me here, having me here, and having had the opportunity to give this presentation.
Dr. Schneider, thank you very much.